AMD coming in with the big brain moves. What if I told you there's now a kernel module officially supported, fully documented? It has been for a little while, although they just updated the GitHub a couple of weeks ago at the time that I'm filming this, for controlling the system management interface. I'm talking Infinity Fabric, I'm talking DDR clocks, I'm talking basically everything that you have in the Ryzen Master desktop software, but for Epyc. It's not a succinct intro, but that's the best I can do. This is actually genuinely very exciting. We got to take a look at this from AMD. It's actually two things. HSMP, which is part of the Linux kernel, has been for a little while, and E-SMI, which is an interface for it. But you don't have to use their interface, you can do your own. Okay, we're going to flip back and forth a little bit between my H-top display here and terminal capture to show you what's going on. HSMP is the system management interface for stuff at a low level, like the Infinity Fabric and the Infinity Fabric clocks and power states. The GMI links, if you want to fold those into for, power saving or something like that. DDR5 characteristics, you can read the number of joules that the socket is using, the energy consumption. You can play with the TDP, the CTDP, configurable TDP, on the fly. I had a problem a couple of months ago where the backup generator for the data center could not keep up with grid mains, and so the data center was looking for a way to not take the jobs completely offline, but reduce the amount of power that the systems were using, because it was borderline, and this would have been perfect. So I'm glad that we have a solution now for this sort of thing, because I can just tell all the machines in the fleet, hey, you use 200 watts now instead of 400 watts, and that's a pretty good stopgap. And this is all documented, well, mostly, on AMD's website. The PPR, the Processor's Programming Reference, Family 19H, and also two GitHub URLs, which you'll find below or in the thread on the Level 1 forums. And HSMP is built into the kernel, but I had some trouble using that, and there were two reasons. One, I needed a newer kernel, 6.8. I mean, it's supposed to have been there since like 5 point something, but adding support for newer processors is kind of a bleeding edge thing, and it doesn't seem like they always backport to the older one. So 6.14.4 is what I've used using the mainline installer thingy for Ubuntu 24.04 LTS. So I'm using a newer kernel on LTS than LTS ships with, but hey, that's okay. You can also download AMD HSMP from the GitHub repository, but as the repository says, it's built into the kernel now, so that's probably not a thing. Then there's E-SMI. Now, E-SMI is the interface for these mailboxes and stuff that you'll find in proc. So you can build your own shell scripts, as I have done, in order to do this, and also that I've cribbed from some very smart people. You know who you are. Thank you. So here's a quick demo. Let's just run the test mailbox. This is a thing that increments by 1. So I run this and it returns 1 more than I sent it. This is a test mailbox feature. Make sure that the driver and the interface and everything else is working. I run that. Yeah, this is really no more complicated than this. Now, if you check the manual that comes with E-SMI, it provides a lot of documentation about how it works, but understand that the interfaces that it's using come from that processor programmer's reference. And the processor's programming reference is somewhat, it's verbose in some ways, but it's not super verbose in other ways, and so you really have to fiddle with it a little bit in order to understand everything that's going on there. So our system here, this is with a Supermicro H13 motherboard, and that supports up to, I think, a 400 watt CPU, and I have our 9575F in here, 64 core, 5 gigahertz system. Now I'm going to be doing some gaming on this system in another video, and because I'm going to be doing some gaming on this system, probably with a 5090, I wanted to be able to adjust a few things, squeeze a little bit more performance out of it, maybe go for some records, I don't know. And in doing that, it's handy to be able to fiddle with the Infinity Fabric clock, maybe some of the memory power states and some other tunables like that, because DDR5 and the Fabric can clock dynamically for power saving. Heck, with the dual CCD links I mean, this is a single socket system, but with the dual CCD links and everything else that's going on in the system, you can put more power or less power. I'm using StressNG. I'm going to run StressNG on, say, 40 of my 128 threads or 42 of my 128 threads, and we can see from the little script that I've put together here that most of our CPUs are are running at 5 gigahertz or very close to 5 gigahertz. This is just a top busy CPUs script that is checking proc CPU info to see what the clock frequency of the CPUs is, and then sorting by CPU frequency and grouping them together. And the ones that are running at 1.5 gigahertz are basically idle. That's where most of them are. Now around 40 threads, I found, is sort of where the cutoff is, where most of our cores are running at 5 gigahertz or very close to 5 gigahertz. And as I start adding more cores, the speed will back off. But if I set the processor socket power to, say, 200 watts, 220 watts, something like that, boom, now we're all running at about 4.2 gigahertz on our 40 thread Stress NG benchmark. And we can see the output in top as well, all those red CPUs that are super busy. They're just leaving it to the operating system to schedule this. If you have a more serious workload, because Stress NG just lives on the core, it doesn't stress the fabric, it doesn't stress memory, then you can be running a workload while you're doing this. Understand that every time you run this SMI thing, you do have a few microseconds of system pause while it reconfigures itself, because it's the system management bus. But if you have a real world workload that you're running with this that you need to tune, say an IO workload or a networking workload, where you might prefer core clock speed, or you might prefer Infinity Fabric, or you might prefer something else, you can configure that. Now, in the Zen 5 desktop video, I noticed there were some BIOS options exposed to do with prefetch and streaming prefetch and that sort of thing. I know more about that now, and in this context with the server processor documentation, it actually makes a lot more sense. So you can configure things like prefetch as well through this interface. Some software will have a huge amount of data that it's working on, and then it will write to memory. And for the purposes of like the cache context, when we're talking about, you know, megabytes or maybe a gigabyte at most, it is not going to read the information, it's not going to need the information that it just wrote to memory ever again, should that be cached. There are options here to tell the system, no, don't cache that, or cache that anyway, depending on the level of software optimization that you're working with. The stream write will really quickly kick everything out of the cache, which will kill performance for everything else as well. So this gives you some knobs and tunables to be able to test your workload against specific things. And this is a heck of a lot faster than rebooting into BIOS, changing some options, and then coming back here to see, back in your operating system, booting it up, doing everything else, to see what sort of a difference it makes. So this is really awesome to see this level of documentation and exposure from AMD. Like maybe they've been doing that the whole time, but I didn't get the memo, so that might be a me problem. But this is great. This is fantastic. This opens up a whole world of possibilities, and this opens up the possibility for building desktop class software. In the level 1 forums, there's dozens, maybe 100 people that have built workstations around Epyc, partly because of the lag time from, okay, Zen 5 is out on Epyc and you can get, you know, 5 gigahertz clock CPUs, and then Threadripper comes later, and so it's just like, okay, I have to have the latest thing, I'm going to go for Zen 5. This gives you some knobs and tunables that really let you dial in your workload. Not that you're going to get, I mean, Threadripper is still going to outperform Epyc. The Threadripper CPUs are just pushing everything, but if you have to have it right now, this does give you a ton of knobs and tunables. I mean, bottom line, it's a lot of documentation about how the SMI interface works, not just for simple things like power socket, but there's MSRs for basically everything. It's just a question of getting documentation and having some utilities. And so I'm cautiously optimistic that AMD is going to do more of this kind of thing, because this is pretty exciting. Check that out. And I love being able to do some tuning here and just squeeze a little bit more frequency at a cost of, you know, power somewhere else. It's like, okay, we're going to run all our PCIe devices at Gen 3, and we're going to run the fabric a little slower, but everything that lives on the core, oh, I can get that 5 gigahertz across an ungodly number of cores in our 64-core CPU. I mean, 40 of 64 cores running at 5 gigahertz for Stress NG. Well, I ran Stress and Stress NG. That's really impressive. Like, just bottom line. And then being able to go in and say, okay, I can see that the fabric isn't being used, let's turn it up another notch. That's really exciting. And what is level 1? This has been a quick look at E-SMI and HSMP, the new HSMP new kernel module. And yeah, this is a lot of fun. You know, good job. All right, I'm signing out, and happy playing with your new kernel modules and software and/or shell scripts. All right, if you have any questions or anything, I'm in the forum. Signing out, and I'll see you there.